6 we are on.
I don't remember.
Yeah, how do you know that?
26.
But like, I
All
didn't.
right, number 26. All right.
Can I please? But it's so fun.
That one? All right, so it says, use what you know about completing the square, change the equation in vertex form, then graph the function, identify the x-intercepts as exact values. Okay. So let's complete the square. First thing, making the space. Good?
Yeah.
Half of 8. 4 squared.
16.
If I add 16, I can add 16 over here, or I can subtract it over here. Agreed? Now, don't get caught up. Too much talking over here. Don't get caught up in the thing where you could say, oh, look, 16 and minus 16, they cancel. I understand. We're not doing that. This is my complete square polynomial. So, what does that factor to?
X minus 4 squared.
X minus 4 quantity squared. Good. And then minus 12. So I have a vertex at 4, negative 12. And then I'm going to make a little room for this. So, 4, negative 12. I can do that.
Is it minus 16?
Oh, it's minus 10, isn't it? Minus 10, thank you. Is that where my that what you saw? Okay, cool. Am I good so far? What? Good? It's like an awful lot of talking. Give them one warning, they keep going. All right. 6, 7, 8, 9, 10. We agree with that as far as vertex. And if I pattern graph, look like lead coefficient was 1, so I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, right 1 up 5. And then, let's see. So I have an answer there, so that's 7. That's 4 and 7. Positive 4 and positive 7. Is that right? So positive 7 and positive 1 are my real roots. And they are rational because we can see exactly where they cross. And then pattern graphing works off it. What else did we come across on the homework?
23.
2, 3? All right. Number 23, 3x squared plus 12x plus 11 equals 0. We want to solve each. First thing, maybe just divide everything by 3. And I'll make the space at the same time. Is that okay so far? All right, let's complete the square. Being we're trying to get it equal to 0, or we have 0 on the other side. So half of 4 is 2, 2 squared is 4. I'm going to add 4. Here's my complete square. And then I'll subtract 11 thirds, so I know that that's going to be 12 over 3. 12 minus 1, or 12 minus 11 is 1. Is that okay so far? Did I do it right? Okay. Root. There you go. Don't forget the plus minus. So I'm going to get x plus 2 is equal to, we need to multiply top and bottom by root 3. So on top, I'm going to get plus or minus root 3. On bottom is root 3 times root 3, which is root 9. Root 9 is 3. Subtract 2. There's a nice exact answer there. Okay, and that would be an irrational answer because I don't know exactly what square root of 3 is. I know approximately. Yeah.
So on the one like with 26, where you were adding it two numbers to the same side,
Mm-hmm.
the first number is positive and the second number is negative.
Mm-hmm.
And then if it's a 0, it's
Then you just go to the other side of the equal sign. So on this question here, it's a great question. So I could have on here, if I added 16 here, I could have went plus 16 over here. But think about how, if I were to move this 16 back over, I would subtract it, right? So that's what's taking place there. I call this the daylight saving time, where we steal from the front to add to the back to act like we get a different number. You know how we rob from the night and put at the beginning of the day to say we have a longer day?
We should just do what Hawaii does. Get benefit.
Arizona, 2.
Made you.
All right. Anybody else have any questions on letter M? It was a newer concept, so it's okay. And Lieb's using his phone.
3.
3.
Ooh.
3. All right, we want to write it as a perfect squared trinomial. What sticks out to me on this one is 4x squared is the same thing as 2x and 2x. 9 is the same thing as 3 and 3. So I believe this is just 2x plus 3 quantity squared. And how we can check that is that times that is 6x, double that, 12x, done. It works out. It's a perfect squared trinomial.
We do 17.
Is that okay? Is that what you asked for?
Yeah.
17. 17. 2x squared plus 4x minus 7 equals 0. Mr. Watson, you're over here just talking, taking away from everyone else over here. Okay. All right. Hey, I want to solve this one on a complete square, so I'm going to divide everything by 2 first. If I divide everything by 2, I get this. Is that okay?
Yep.
I guess technically I could move that 7 over 2 to the other side, but as of right now we're okay. Half of 2 is 1. 1 squared is 1. So if I add 1, I can subtract 1 here, or I could just add it over here. It's your choice. Is that okay? Here's my complete square. So that's x plus 1 quantity squared equals, I can move that over, plus 7 over 2. So that's the same thing as 2 over 2. So x plus 1 equals 9 over 2. That okay?
Yeah.
Favorite thing is root. So I get x plus 1 equals plus or minus 3 over root 2. I can't have that. Almost by both top and bottom of root 2. 3 root 2 over 2. Subtract 1. Do what?
9.
You had 9 so I just broke this into this. That gave me this. And then I multiplied top and bottom by root 2 and root 2, which gave me the 3 root 2 over 4. Or 3 root 2 over 2. I was just rationalizing it as I went along. Anything else? Going once.
You do 5.
Number 5. Okay, if this was on an ACT or an SAT, this is going to be definitely a perfect squared trinomial. They're just trying to steer you away from it. So you'd have to say, okay, well, x minus and then 1/4 quantity squared is the answer. And you could double check it because you could go negative 1/4 x added to negative 1/4 x is negative 2/4 x. Negative 2/4 x is negative 1/2 x. Or if you know it's going to be a perfect square trinomial, you just say, what is half of that? It goes right there. So double the denominator. Anything else?
25.
2 5s?
Yeah.
Okay, I have a lead coefficient 31, that's fine, so let's make the space. Or I could have moved it to the other side, doesn't matter. Half of 5 as a fraction is 5 over 2. 5 over 2 times 5 over 2 is 25 over 4. If I add it, I can subtract it from here, or I can just add it to the other side. Is that okay so far? This is now my perfect square trinomial. So x, that has to be plus. What was half of 5? 5 over 2 goes right there. And then let's move the 1 over. So this is the same thing as 4 over 4. Root, don't forget the plus minus. X plus 5 over 2 equals plus or minus root 29 over 2. Subtract 5 halves. I guess it's the same denominator, so if you wanted to put it together, you could have negative 5 plus or minus root 29 all over 2, or you could leave it like that. Okay. Make sure your names are on those. And pass them on forward. And remember, I'm not collecting L, so don't. If you have L sitting there, don't pass that forward. We didn't do L.
Take the L, man.
What the L?
Oh.
See what I think of that.
He does come back.
Give me a high five and you're on.
No.
Let's see how this goes. You're lucky your brother was with you there.
Another one? Organizing these.
You know, also in my
He doesn't come back to
Made me feel better about myself.
Hey, what? You know what? When you tell me, it's so weird that not many people know non-rotating. I just found that out. You know, right? I just traded because we had 4. Oh, 5. Discriminate graphs. Yo, I love this.
All right. Everyone get one?
Yes.
Come back. Come back. 3. Bring all the way back. Good.
Yes.
We're good? Okay. Let's go. All right. We're going to understand the derivation of the quadratic formula. But first, let's talk about this picture. If we were to talk about the solutions, which are a lot of times referred to as the roots, sometimes referred to as the zeros, which all really comes down to is where does it cross the x-axis? Okay? So solutions, roots, and zeros are all the same thing. Okay, the hard thing about calling it a zero is if it doesn't cross the x-axis, it's not a zero. But it still could be a root or a solution. So does everyone agree that that yellow line does not cross the x-axis? Is anyone like that? I think it does. So this would have 2 complex solutions, which that means I would have like an answer of 3 plus or minus 2 I root 7 over 4, something like that. Okay? You would have I as part of your solution as your answer. It doesn't cross. Okay? That's also the same thing as the purple. This has two complex solutions as well because it doesn't cross the y-axis or the x-axis. Okay? So this would also have an answer of 4 plus or minus 5i or something like that. Okay? It doesn't have to be over with a radical or anything like that. The blue and the green have one real solution. And the real thing in math is an R with a slash through it. It means you're talking about the real number system. That's the name of it. Okay? This is also, we will start referring to this as a bounce because it bounces off the x-axis from here, or it bounces hitting like the ceiling and down. So I have two complex solutions, which means I have imaginary numbers. I have one real solution, meaning I'm going to have a bounce. It touches the x-axis. And then the red one has two real solutions. They can be rational or irrational, meaning you could have an answer of you could have 2 plus or minus root 5. Okay, that works. Or you could have 7 and 5 over 2 or something like that. Those could be. So these are zeros. So a 0, and these are also zeros. The roots mean that, hey, it could fall into having imaginary numbers, meaning it won't cross the x-axis. And then the solutions are kind of the catch-all for all of them. Is that okay? And I think this will fill in and make a little bit more sense here in a moment. So what methods do we have for finding zeros? We know how to factor, right? Factor, and then you set these equal to 0. So that's one way. You do have the difference of two squares. You might recognize that if you had like x squared minus 4. That would break to x plus 2, x minus 2. These are different things that you have in order to get the solutions. Things that didn't factor when you were in Algebra 1 and even a little smidge of this class, we referred to as prime. Prime doesn't mean that the solutions don't exist. It just means that one of two things are happening. If it doesn't factor, you might have complex solutions. You might have the imaginary, the I in there, or you might have an irrational solution. So 3 plus 2i, or 3 plus root 2, things like that, okay? And you did learn the quadratic formula back in Algebra 1, at least you should have. That was part of the standards. And then there was other things where you could look at the graph and you could find out where it's crossing the x-axis. Sometimes you might be able to say, well, I can approximate where it crosses the x-axis. So there's different methods that you had been taught over years. Okay? So how do these methods know we have an irrational number? Well, irrational means that I'm going to get like square root of 5 or square root of 3 or square root of 2 as part of my answer. Okay? Those, if I go and take it on my calculator, it goes all the way across the screen to 8 or 9 digits. Okay? It doesn't mean that it's like an 8 or 9 digit number. It's your calculator truncates it off. If you were to pull up on, I'm sure there's a website out there that you can say, hey, show me the square root of 2 out to 400,000 spots. You can see it, and you're not going to see any patterns to it. It's like pi. Okay? The imaginary number means that I would have had, when doing this, I would have had a negative under my square root sign. Okay? Imaginaries always come in pairs, whereas irrational don't have to come in a pair. So you have to have a positive or negative component if it's imaginary. Seem okay so far? All right. How do we know if the graph is a rational number, irrational, or imaginary? Didn't we just cover that? How do we know from these methods? Okay. Let's move on. All right. So, some of you might have, if you had a good Algebra 1 teacher, you might have seen this before. If you didn't, you might not. Okay? I am going to take ax squared plus bx plus c equals 0, and I am going to complete the square on it. Meaning, I'm going to now try and solve it for x. So what was the very first thing we needed to do before we made a space when we complete the square? Yeah.
Half of the thing.
Nope. Very first thing. Didn't mean it. Not a space. Before the space.
Set it equal to y.
Nope. Nope.
Subtract.
Nope. Divide by a. Thank you.
Oh.
That's the first thing we're supposed to do, right? Because here it's going to go x squared b over a x plus c over a equals 0. Agree? Any part of that that's goofy? Can I keep moving? All right. Next complex part is let's make a space. Is that okay? All right. What is half of b over a? What is half of b over a?
What?
What is half of b over a?
1/2 b over a.
Yeah, so what do I do if I take half of a fraction?
1/4.
I double the
You double the denominator.
denominator, so b over 2a.
Oh.
Okay, so that's there. What is b over 2a squared? So what's b times b?
B squared.
b squared. What is 2a times 2a? 4a squared. So this here is my perfect square trinomial, meaning if I were to take x plus b over 2a and x plus b over 2a, and I was sick and demented in my mind and I wanted to just double distribute it out or FOIL it out, that's what would happen. Okay, but if I added it here, I need to also add it over here. Is that okay? Yes, I could have subtracted it from right here, but I have an equal sign so I can put it on the other side. So if I add it to one side, I have to add it to the other. So here's my region that I add to both sides. Everyone agree with that? So my next step is I have b squared minus 4a squared minus that c over a. Okay? What is my common denominator, Mr. Watson? 4a squared is one denominator, the other one's a. What's my common denominator?
A.
Close. Closer.
2a squared.
Almost.
4a squared.
4a squared. So I'm going to multiply this by 4a and 4a. Agree? So that's going to give me a common denominator between those two.
Yep.
Okay, so I'm going to just write this. A 2a squared equals. So that's going to give me 4a squared. So that means that I have b squared minus 4ac on top all over 4a squared on bottom. Okay, how do I get x by itself? Square root. Don't forget the plus minus. Okay, so I get x plus b over 2a. Is 4a squared a perfect square? So what's the square root of 4a squared? 2a. Agree with that? That makes sense so far? Now I can get x by itself. I can subtract b over 2a from both sides. Do I have the same denominator? So you will know that x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a.
Why would we just do all of this?
Ben knows nothing.
Can we leave
Screw you,
the,
Cooper.
like, on the top.
Wait, can you scroll?
Do what?
Can we leave it like?
Oh, I know that song.
That? Sure. But this is the quadratic formula.
This ray is dangerous.
I didn't learn quadratic.
Huh?
So I already did, why did we do the whole?
To show you that they didn't just make it up mathematically saying, hey,
I
plug it in.
figured, I just assumed.
But now we proved it.
Yeah.
Yeah, baby. So we just moved up a league in math.
Ah, you did improve. Except it's not geometry.
No, it's not geometry.
All I'd have to do is make it algebraic proof, is list all the reasons why all the way through, which I guess I could do. But I'll do it a different day. So you've seen this? Yes?
Yes.
Cool. Let's move on. This works for all the quadratics out there. This allows you to find all of the solutions or the roots or the zeros if it works out. Okay? This is one of the formulas that needs to be a go-to. It's kind of like area of a rectangle is length times width. It's a go-to. You need to make it a go-to. Okay, yes, the song is goofy, it's dumb, but you know what? People will be humming it when they have to know it to get it through their head. Okay? All right. So, there is one part of this. There is one part of this right here. B squared minus 4AC. That will tell you how many roots and what kinds of roots you will have. Because it's a square root sign, if it's negative, once you've done the arithmetic underneath there, that would tell you you have imaginary numbers. If you did b squared minus 4ac and you did the arithmetic underneath there and you came out with a 0 underneath the radical, then you have one solution. That gives you the bounce. That's one of those that bounces off the x-axis, either coming down and bouncing off or coming up and bouncing down. Okay? Or if b squared minus 4ac is any number that's not negative or 0, that would tell you that it's going to have two solutions that are real. They could be part of the rational numbers if you could figure out what the square root of it is exactly. Or if it doesn't have a square root, then it's part of the irrational numbers. So like if it came out to square root of 7, you can't find the square root of 7 exactly. Can I move on? All right. So if the value under the square root is positive, oops, let's make it better color than that. If it's positive, then you have two real solutions. If the value under the square root is 0, then the equation has one real solution. And if the value under the square root is negative, then you have two imaginary solutions, which are part of the complex numbers. Is that okay? I'm sorry, I pop with way too much. All right. So the discriminant of the quadratic equation is what b squared minus 4ac is called. We call it the discriminant. The expression b squared minus 4ac for the quadratic of ax squared plus bx plus c equals 0. Also the expression under the radical in the equation of the formula. And then used to find the number of type of solutions. So again, if your discriminant is positive, then you have two real solutions. If your discriminant is 0, you have one real solution. If your discriminant is negative, then you have two complex solutions, which are imaginary numbers. Is that okay? Moving on. All right. Find the discriminant of each. So the discriminant is b squared minus 4ac. You know that's a, that's b, that's c. Agreed?
Yes.
So that means that I'm going to get 25 minus 4ac. So 25 minus 8 is equal to 17. If you had a 17 under the square root, that makes it an irrational number, but there's going to be two of them where you would cross the x-axis. Those are your solutions. They are real solutions. Okay, so again, I'm just using what is underneath the radical to determine what kind of solutions I have. If I were to use the discriminant on this next one, if I had b squared minus 4ac, and again, that's a, that's b, that's c. Make sure you understand that there's negatives that are involved. B squared is 9 minus 4 times a times c. So I get 9 plus negative 56, which is negative 47. That means I have a negative underneath the square root. If I have a negative under the square root, that means we have two complex solutions, which are imaginary numbers. So how many and what types of zeros did each of the above have? Well, this one would have given me root 17. So those are two real, and they happen to be irrational, because you can't find the square root of 17 exactly. It's 4 point something, goes on forever. Okay? This one, if I had the square root of negative 47, because I have a negative underneath the radical, I have two complex, a c with a slash through it, which these are imaginary. It means you're going to have I as part of your answer. Okay? If you have I as part of your answer, technically with quadratics, it will not cross the x-axis. It'll cross the y-axis. All quadratics do, but it doesn't cross the x-axis. This one will indeed cross the x-axis at about 4 point something, or whatever the rest of the answer is. Can I move on? Am I losing anybody?
What does it say in the form?
Imaginary, or image, I-M-A-G. I didn't know how to spell imaginary, so I just stopped. Or wait, I should have said I ran out of room, so I just abbreviated it.
There you go.
What teacher would know how to spell?
You're a math teacher, you don't need to know how to spell things.
My youngest daughter has this weird ability. She can spell a word frontwards and then she spells it backwards just as fast. It's really strange. She's like, oh yeah, I just see the letters come to me and then they go back away from me. I'm like,
Yeah.
like I knew I was weird in the head, but man, my daughter, she's just a whack job. I'm just kidding. 14. All right. Use the quadratic formula to solve each equation. Answers must be simplified. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Okay. Did I do b squared? Yeah, it's 36. All right. All right, so negative 6 plus or minus 36 minus 116, negative 232. Negative 232 over 2. Negative 6 plus or minus negative 196 over 2. What do you know about that? There's got to be an I. Anyone know what the square root of 196 is? 14. Right. Good job. So I get negative 6 plus or minus 14i all over 2.
So we don't add the x.
No. This just tells you where it's crossing the x-axis, where the solutions are. I can reduce this because 2 goes into there and goes into there. So I'm going to get negative 3 plus or minus 7i. That right there is called your solution to the problem. If you plug that back in, your answer would come out to be 0. So negative 3 plus or minus 7i. Complex, yes, because there's I. How far am I? Am I almost there? Yeah. All right. Does anyone need me to go through this one here? make sure you plug into this. Make it to 0. Have you all used the quadratic formula before? Do I need to walk through them?
No.
Anybody? We're good? All right. Quadratic. All right. So now we want to start working backwards. So I want to figure out what the trinomial would be that had that for a solution. So my first step is this. What did I just do?
Multiply everything by 2.
Yeah, I multiply both sides by 2. And then I can do this. Okay, I technically have the plus minus here. I'm not going to worry too much about it right now. So I get to that point. So rather than saying 2x plus 5 minus root 17, how do I get rid of the root? What do I have to do to both sides? Square it. So I'm going to put that in parentheses. Square, square. So I'm going to get 4x squared plus 20x plus 25 is equal to 17. Subtract the 17. So this quadratic here, if you were to plug that back into the quadratic formula, those are your answers. Okay? So move the denominator over by multiplying both sides. Move the portion of it that is the whole number over. And then you have to square both sides. Can I move on? So then how do I do it when there's an I in there? Well, see if you can follow along. Agree?
Yeah.
Subtract the 9. Agree?
Yep.
Okay, I don't like this, so I'm going to square it. I don't like this, so I'm going to square it. So that's going to give me 4x squared, 36x, plus 81 equals I squared. Oh, we learned what I squared is, didn't we?
1.
Not 1.
Negative.
Negative 1. Agree so far?
Yep.
Add 39 to both sides. Let's see, 81 and 39. I can't do it in my head. I'm sorry. Is that 140? Is that right? 120. 120. Right?
Yep.
Okay. So this quadratic here, if I did the quadratic formula, that's my solution. Those are my solutions. Okay? Is that it?
Yep.
Dude, I got done? Oh, best day ever. All right. Worksheet N. Worksheet N. So this week we'll check off N tomorrow, go over any problems. We have a review that we'll be working on because we have our quiz on Thursday.
How many points is that quiz?
I don't know. About the same as everything else. I love that. Was a fun lesson today.